Yes, and welcome to Module 3, Lesson 11, more angled problems and solving equations. Okay, so this Lesson 11 is going to continue where Lesson 10 ended, and it will also incorporate slightly more difficult problems, right? So at the heart of each problem is the need to model the angle relationships, okay, such as vertical angles, adjacent angles, angles on a line, angles on a point, okay? To model those angle relationships in an equation and then solve for the unknown angle, all right? Now the diagrams are all drawn to scale, so they say, so get ready to verify your answers by using a protractor. It'd be good to start using the tool if you haven't already. Start using it in earnest to measure the relevant angles to check, okay? So a protractor might be in order, okay? So let's get started. Okay, our opening exercise here asks you again, having done Lesson 10, this will be no stranger to you, this whole idea. We'll be actually working these problems just like we did in Lesson 10. So, in a complete sentence, describe the angle relationship in the diagram, and then you're going to go ahead and write an equation for the angle relationship shown in the figure and solve for x. All right? And then go ahead and, again, I can't see that you're doing this, but hopefully you will. Go ahead and confirm your answers by measuring the angle with a protractor. It would be good to start working with a protractor. If someone has difficulty working with a protractor, well, maybe that's something we should do in class. I'll just plan on doing that next time we meet. Okay, so go ahead and do that and come on back. Okay, so the complete sentence that I wrote, hardly a complete sentence. I don't know, maybe you are writing more complete sentences than me, but I wrote the angles marked by, what's the wrong thing I want to use? The angles marked by x degrees, 14 degrees, and 90 degrees. Now, of course, it wasn't marked 90 degrees, but of course, our little square here in the corner tells us that it is indeed 90 degrees, okay? So it might be a good thing just to start off with that. All right, 90 degrees. This is what we knew initially. They all equal 180, okay, because they are angles on a line. All right, so x, of course, that makes sense that x plus 90 plus 14 equals 180. X plus 104 equals 180. And then take away 104 from both sides, and we have x equals 76. So 76 degrees is x degrees. X equals 76, therefore x degrees is 76 degrees. Okay, add all three of those together, 76, 90, and 14, and you will get 180 degrees. You can check that with your protractor if you would like. Just go ahead and measure that angle right there. Okay, here's the next one. It says CD and EF are intersecting lines. In a complete sentence, describe the angle relationships in the diagram. Write an equation for the angle relationship shown in the figure and solve for y. Okay, we're solving for y now. Confirm your answers by using a protractor. Okay, same idea. Go ahead and do this and come on back. Okay, so again, a really easy one to figure out yourself without any kind of algebra, but going through the process real important. And again, this idea of writing all of this down, the sentences concerning the relationships with the angles, really good. Kind of just get you thinking on paper, you know. So the adjacent angles marked by y degrees right here and 51 degrees right here, okay, together form an angle that is vertical and therefore equal to an angle measuring 147 degrees. Okay, and that's this one right here. And you can see that these two are vertical. This one and this one. Okay, because that includes these two and that includes that one there. So they are vertical. All right, so they are equal. And again, you can do this in your head really quickly. But if you do it algebraically, y plus 51 equals 147. Get rid of the 51, and y equals 96. So therefore, 96 degrees goes right. Oh, sorry, wrong one. 96 degrees goes right there. Okay? And then, of course, we could figure this one out. Okay, this angle right here, we could figure out through algebra as well, or just in our heads. But we won't because we need to move on. Well, here we go again. In a complete sentence, describe the angle relationship in the diagram. Write an equation for the angle relationship shown in the figure and solve for B. So I'm solving for B right there. Again, look at all the relationships and the relationships that will help you out. Think vertical, think adjacent, think on a line, think on a point. Okay? And so go ahead and do C. You might as well do D. No, just do C. I'm going to come back and do C. I'll do them each one at a time. All right, so yeah, do C and then come on back. Okay, I know for some of you this is like silly easy, but again, if you're creating this, if I'm going to give you an assessment, mid-module assessment, end-of-module assessment, I'm going to need to see all of this. So what I wrote here is just all of the angles shown. 59-degree angle, the 41, the B, the 90, 65, and the 90. All of these are, this is the 90 right here. Again, remember to always to be careful because they're not going to give you the degrees there, but they're going to put that little box. So all of those are going to have a sum of 360. We know that because they are angles at a point. Okay, so just set it up like that. All of those equal 360. Now we have B plus 255 equals 360. Again, take away the 255, we end up with B equals 105, which is our answer here. Okay. Again, easily done arithmetically, but I want you to do it algebraically. Okay. So here's D. Again, the following figure shows now three lines intersecting at a point. Just throw a little twist into the mix here. In a complete sentence, describe the angle relationship in the diagram. And then again, write an equation and go ahead and we are going to solve for Z right there, angle Z. Okay? Confirm your answer with a protractor. I don't know if that would be messy or not, but you can give it a try. All right, so yeah, go ahead and come on back. Okay, so I saw that the angles Z, 158, and Z, okay, we know those two are going to be the same, are angles on a line and equal 180. Okay, so now I'm going to go ahead and just erase that. That's what I went by because I saw the line right here. Okay, looking at that line. All right, and I saw that those are all angles on a line. They're going to equal 180. So I'm going with that relationship to help me solve. So I'm going to go ahead and just erase all this, and I'll be back with my solution equation and solution. Okay, and here's my solution for this one. Put it all together. Z plus 158 plus Z equals 180. 2Z plus 158 equals 180. Take away that 158 from both sides. Get 2Z equals 22, and therefore we're going to multiply both of those by the 2's reciprocal, which I didn't actually show, but pretty obvious by now, hopefully. And you end up with Z equals 11. So both of these here are going to be 11 degrees. Okay, so 11 plus 11 is 22, plus 158 is 180. All right, here's E. Write an equation for the angle relationships shown in the figure and solve for X. Okay, I'm going to solve for X. Whoopsie daisy. Won't solve for the X right there. And in this case, we have another X as well. Over here, 5X. Okay. All right, so go ahead and, write an equation for the angle relationship shown and go ahead and solve for X, but then also describe that in a complete sentence. Describe the angle relationship in the diagram. Okay. In the end, you're going to find the measurements of angle EPB and angle CPA. All right. Use a protractor to confirm. All right. Do that and come back. Okay, so the relationship I went for were that all of those angles, CPA, angle CPE, and angle FPB, were all, or EPB, sorry, EPB, are all angles on a line and have a sum of 180. Okay, therefore I'll take all those angles the way they are expressed here to me are one is the x, and we have the 5x, and then we have, of course, that is 90. Again, unwritten, but with the square there, we know that it is 90. Therefore, my equation looks like this: 5x plus x plus 90. All of this here is going to equal 180. Combining like terms, 6x plus 90 equals 180. Taking away the 90, both sides, 6x equals 90. Multiplicative inverse will get us to x equals 15. Okay, but in the end here it asks us for find the measurements of angle EPB and angle CPA. Okay, so we would write that down this way. We can write measurement of angle EPB equals 15 degrees. Okay, because that's right here. Okay, EPB, that's the x. And then the measurement of angle CPA equals actually 5 of those x's. So if we do 5 and then plug in our 15 for our x, we know that it equals 75. So that equals 75 degrees. Okay, and those two together, of course, are 90. Plus another 90 is going to give us that 180. Okay, example 1. The following figure shows 3 lines intersecting at a point. Okay, in a complete sentence, again, describe the angle relationships, and then write an equation and solve for x. Okay, confirm your answers with a protractor if you'd like. And again, think a little bit out of the box this time. Okay, you may see, this may be obvious to you and may not be, but yeah, give it a whirl and come on back. Okay, so this is how I wrote it out. It's a little bit long, a little bit maybe not confusing, but you tell me. So what I know here, I can tell the relationships here. I know the angles 86 degrees, 68 degrees, and the unmarked angle. So these here, this unmarked one, okay, they are going to equal up to 180 degrees, as they are angles on a line. Okay, as you can see that. Now I know that part. I also know that the unmarked angle is vertical to x, okay, with which it is equal. Okay, that should be is there. With which it is equal, and I know it's equal to x because it is vertical to it. Okay, so therefore I know x is equal to that unmarked spot. So I can just go ahead and substitute x in here. So I have 86 plus the x value, and then plus 68. Okay, so all of these here I'm adding together, and I'm using this because I know this is equal to that. Okay, and so then just continue on. X plus 154 equals 180. Got rid of the 154 from both sides, and I end up with x equals 26. Okay, so we solve for x, and x equals 26, and we can confirm that. 86 plus 26 plus 68 equals 180. Alrighty, so let's get down and let's do exercise 1. Okay, so the following figure shows 4 lines intersecting at a point. In a complete sentence, oh man, I'm getting tired of saying this, but I'll say it anyway. Describe the angle relationships in the diagram, write an equation for the angle relationships shown in the figure, and solve for x and y. Okay, a little bit different here. Confirm your answer with a protractor. All right, you're going to solve for both x and y right there. Okay, so get an idea of what you can do and which relationship you'd like to use. Write out that relationship and then go ahead and create your equation and solve for x and y. Okay, so there are a couple of things I notice in this diagram that are going to help me out, make it all very simple. I know that the angles marked x degrees, that one right there, and 25 degrees there, y degrees there, which are marked, and then 40 degrees right here are all, as you see, angles on a line. Okay, therefore, they all together equal 180 degrees. All right. And then I also know that this y unknown here, this y is vertical to and therefore equal to a 96-degree angle. Okay, so I have already, didn't even have to solve actually for y in that sense, because I can tell what it is there. So I'm just going to go ahead and plug that in right here, as you see. X plus 25 plus the 96, which I figured out, and plus 40 equals 180. X plus 161, take away the 161, x equals 19 degrees. Okay, so right here is 19 degrees. If I add all those up, 19 plus 25 plus 96 plus 40, I do indeed get 180 degrees. Here we go again, example 2. In a complete sentence, describe the angle relationships in the diagram. And it says here you may label the diagram to help describe the angle relationships, okay? Because that may indeed help if you need to. All right, so what you're going to do is you're going to write an equation for the angle relationship shown and solve for x. Confirm with a protractor. Okay, so there's a few things I saw in this one as well. Now, when they asked you, you may label the diagram to help describe the angle relationships. You'd only need that if you were going, writing a sentence like I did here. And hopefully you are practicing this, at least, verbally describing what you are doing when you are doing it, okay? So I said the angle formed by, how many times have I done that? The angle formed by the adjacent angles A degrees and B degrees, which are these that I labeled myself. That angle right there, that those two form, okay, right there, it is actually vertically opposite. Okay, it's vertically opposite to this angle here, which I know it's labeled as 77 degrees. Okay, so as that is labeled 77 degrees, I know that these two together are going to be 77 degrees. Okay, and I also know that if I put x degrees, which is right here, and added that plus x degrees plus a degrees plus b degrees, that equals 90, because that sits on a 90 degree angle right there. Right there, 90 degrees. Okay, because this here, the box is 90 degrees. Therefore, I know that this the one next to it is going to be 90 degrees as well. Okay, this entire thing right here I know is 90 degrees because I know this. Okay? Therefore, I could set up my equation as x plus 77 equals 90. Okay? And then just go through the process. And I get x equals 13. So 13 degrees right there. Okay, here we go again. In a complete sentence, describe the angle relationship in the diagram. Write an equation for the angle relationship shown in the figure and solve for x and y. Confirm your answers with a protractor. Okay? So yeah, go ahead and do that. Do exercise 2. Come on back and we'll look at it together. Hopefully it's getting easier and easier, especially the part where you write the sentence. Okay, so please practice at that. Okay? Okay, in this one we can see that angles x and y have a sum of 90 degrees. Okay, x degrees and 90 degrees right here. And x degrees and y degrees right here. We know that's equal to 90. Okay, and I don't just guess that it's equal to 90, but I know it because I know this is 90 degrees right here. Okay, and those two angles, this larger angle here and this one, are angles on a line, and they're going to equal 180. Okay, I know that. And I also know that angles x plus the 27 degrees over here, this is another example of another 90 degree angle over here, 90 degrees. Okay, and again I know that because it is also adjacent to a 90 degree angle, okay, on a line. All right, so I know those two things. I know that x and y have a sum of 90, and that x plus 27 have a sum of 90. Okay, you can tell already actually what what the measurement of y is already pretty clear. But let's go ahead and do it algebraically. X plus 27 equals 90. We come to the point that x equals 63 degrees, and then 63 plus y equals 90, y equals 27 degrees, okay? 63 degrees, and that is 27 degrees there. Okay, so for the sake of not repeating myself over and over again, just go ahead and do both of these as example 3 and the exercise 3. Okay, now again, describing the angle relationships in a complete sentence, and then writing your equation and solving for what they want you to solve for. Okay? Just pay attention to what each problem is asking you to solve for. And then come on back. Okay, I'm solving one at a time, but if you've solved them both, you can just continue this and don't pause after I'm done with this explanation. Okay, so this one is interesting. Looks a little bit different. If you notice this right here, and the way you describe where it's located uses a word called subtends. Okay, subtends. I'm not sure if this is actually going to come up again, but let me just go ahead and read what I wrote here about describing the angle relationship. So I said the sum of the measurements of angle JAH, angle GAH, and angle GAF, and the arc beneath angle JAF, okay, is 360. So that idea of the arc beneath, or the arc that subtends angle JAF, okay, and angle JAF is right here. That's JAF. Okay, there's that angle, this large angle right here. This is 225. This arc subtends that, or sits below that, as you can see. Okay, that is 225. Okay, and you can see that arc symbol is right over here. That arc. Okay. That measurement is going to be the same as an angle. It's also an angle measurement as well, okay? But all of those put together are going to be 360, because if you take all of those and put them together, you can see that it's a it's a circle, okay? It creates a circle which has 360 degrees, all right? And so the way to go ahead and put that into equation would be right here, 225, which is that arc, okay? 2x, which is that. The 90, which is this over here, is 90. Okay, again, unwritten, but we know because of our square. And then 3x. Okay, all of those together equal 360. Go ahead and combine our like terms. 315 plus 5x equals 360. You guys know this drill pretty well, I'm thinking, huh? Take away the 315 from both sides. End up with 5x equals 45. Multiply by the multiplicative inverse, and we end up with x equals 9. Okay, and of course that's not the answer to this question, because they want us to find the measures of angles JAH and GAF. Okay, so to do that, JAH first, we can see that that is actually equal to 2x. So if we do 2, substitute our x, so that's going to be 18 degrees. Okay, 18 degrees. So angle, we're going to write this as a complete answer here. I'll put angle, the measurement of angle JAH equals 18 degrees. Okay, and now for GAF, which is right here, that's 3x degrees. So if I do that over here, 3 times the 9, because that's what I solved 9 for, and that equals 27. All right, so this is 27 degrees. And then a proper answer would look like this. The measurement of angle GAF equals 27 degrees. Okay, I'm not really sure if my solution to this problem was recorded. I can't tell, so I'm going to do this all over again. If I have already, if you've already seen this and I've actually gone through this already, just move ahead. But okay, so yeah, so I wrote down here the sum of the measurements of JAH, GAH, GAF, and the arc beneath JAF is 360. So I was talking about this arc right here. This is that arc right here. It's 225 degrees. Now that arc, we say, actually we use this vocabulary here. We use this word subtends, okay? That means it's below this JAF angle. So this angle right here, this arc subtends it, okay? It's down there. So what we can assume then is that this whole thing is a circle, of course, all right, where these are written, but this has an angle. This whole obtuse angle right here, this whole large thing is 225 degrees, or that arc is 225 degrees, and we know a complete circle is 360 degrees, okay? So we know that that's 360 degrees. So then we could just create an equation from there. With 225, we had that arc right here, 225 plus the 2x, the 90. Okay, and the 90 we know because of the little square there. And then 3x equals 360. Again, go through the whole deal here, making zeros, making ones, and we end up with x equals 9. Okay, so x equals 9, not the answer, because they want us to actually find the measures of angle JAH and GAF. And the way we do that is by plugging our 9, our solution here, into the 2x here. So if JAH is 2x, that means it's 2 times 9, which is 18 degrees. Okay, and then the other one, the other angle, GAF, is 3x, so that's going to be 3 times 9, which is 27 degrees. And that's right here. And up here, I've written them out the way they should properly be written. The measurement of angle JAH equals 18 degrees. The measurement of angle GAF equals 27 degrees. Okay, so here's my little explanation here, description of angle relationships in this diagram, exercise 3. The sum of the measurements of LKJ, JKJG, and GKM, and the arc that subtends, again this word subtends, I'm using in case it comes up, again, which means that arc that comes underneath, that's right here, okay, and is all 300, they all equal 360, so the whole sum of all of that, of course, because again, just like the one above, we're looking at a circle here, okay, so this plus this plus this plus this, which we know is 90 degrees, okay, that all equals 360 degrees, all right, so we can write that using our variables and numbers that we know already, and I've done that over here. So putting these all together, 5x plus 24 plus x plus 90 equals 360. Through the motions, combining like terms, making 0, making 1x. Okay, so here we go, the sum for exercise 3, the sum of the degree measurements of angle LKJ, angle JKJ, angle GKM, and the arc that subtends. Remember this word subtends? That's this down here, comes underneath this angle right here, okay, this idea of subtends, angle LKM, which is that angle right here, okay, LKM, this arc right here that subtends that equals 360. So all of these, this plus this plus this plus this, are all going to equal 360. We know this is 90, of course, because of our little symbol, little box symbol, okay. I had to do it on another page to solve this, and as you can see, I had solved this and explained this to you already, but I don't think I had turned it on again. All right, Anyway, so 5x, just put them all together. All these that we know and don't know equal 360. Combine like terms. Take away the 114 to make a 0. And then go ahead and multiply it by the reciprocal to get 1x. And then we have x equals 41. Properly stated, the measurement of angle JKG equals 41 degrees. Okay, so one more activity to go here. That is this example 4 here. Okay, it says here, it states, talking about a ratio again, in the accompanying diagram, angle DBE is 4 times the measure of angle FBG. Okay, so find your DBE and your FBG, and know that DBE is 4 times the measure of FBG. Okay. So what? And again, I'll just read these. You can come back and we'll solve them one at a time. The first A part says label DBE as y degrees and FBG as x degrees. Write an equation that describes the relationship between those two angles. Okay. I think it's actually been written in there for you already. It might have been, huh? Yeah, it is. Okay. So it's in there. But anyway, I guess what you need to do here then is just go ahead and write an equation that describes a relationship between DBE, which is here, and FBG, which is there. Okay? What would that relationship, what would that look like? What is that equation? Okay, yes, and that equation is y equals 4x. Okay, because we have y here, and we know that it is 4 times as big as this one, as x. Therefore, y is going to equal 4 times this x. Okay, so that would be the equation. All right. So now, in this case here, I would like you to go ahead and write an equation and find the value of x. Find that value of x. And come on back and we'll check. Okay, so I'm going to find the value of x, and again, I haven't asked you to write anything down this time, or they haven't asked you to write anything down this time, but I'd like to know that you can explain yourself when you do an equation like this. So I'm going to say that I know 50 right here, plus x, which is right here, plus 4x, which is actually the y, is actually 4x, okay, same. They equal up to 180, and the way I know that is that these 3 angles, this angle here, and this angle here, all equal up to 180 because they're angles on a line, okay? And the reason I know to include 4x is because that is vertical to this other angle here. So I know that if this equals 4x, this is also going to equal 4x, okay? So, yeah, then I go ahead and continue and work the magic, combining some like terms, getting rid of the 50, bringing that x down to 1x, and I get x equals 26, okay? So this x here is going to be 26 degrees, all right? All right, so yeah, let's move on to the next one. Okay, so next one, C, is actually asking us to find the measures of these angles, FBG, CBD, ABF, GBE, and DBE. So let's go ahead and look back, and we'll figure this out. Let's just go ahead, and if you want to stop, pause right now, and do this by yourself and come back, that's fine. But if you don't want to, I'm just going to continue talking. So FBG, let's go look at FBG. We have FBG, we know that is 26 degrees. Let's just put that equals 26 degrees. How about CBD? We have CBD, is also going to be 26 degrees, and that's based on the fact that it is vertical to this 26 degree angle over here, okay, and therefore equal. So that is equals 26 degrees. Okay, how about ABF? ABF, well, ABF is 4 times x, and if we know x equals 26, we could just do a little multiplication magic. And that equals, what is that, 104 degrees, okay? So ABF equals 104. How about GBE? We have GBE. Now GBE is also vertical to the 50 degree angle, therefore we know that is 50 degrees. GBE equals 50 degrees. And finally, DBE, which is right here, which is also vertical to this angle, which we now know is 104 degrees. Therefore, it is 104 degrees as well. Okay? So you can see all these different pairs of vertical angles we have. All right, and now D asks us, what is the measure of ABG? Okay, and now we need to identify the angle relationship we used to get our answer. So let's go back and look at ABG. And maybe I'll tidy up before we go through it. Okay, so we were asked to find the measurement of angle ABG. And to do that, very simply, all we need to do is add these two adjacent angles, 104 degrees and 26 degrees, and that would give us the measurement of angle ABG equals 130 degrees. The angle relationship I used pretty much, I guess, was just the idea of them being adjacent, and then you can add two adjacent angles together to get the measurement of the larger angle that they create together. Okay? Alrighty, well, I'm flipping the page over here and I see that the exit ticket is next. That's for you to do. So go ahead and do your exit ticket, do your problem sets. Any problems you run across, go back and maybe look through these videos again, or just give me a call. Okay, good luck with this, and yeah, see you soon.